Recall from the last video that a tributary area is an area of the load that the supporting element underneath it supports. We looked at simple cases of supporting beams running parallel to each other, like the three beams underneath this bridge supporting that bridge. In this second video, we'll look at slightly more complex supporting structures. Let's consider that our supporting structure for the concrete slab consists of two joists and two girders connected at their ends at right angles to each other as shown here. All of the supporting members are located on the same plane. On top of the supporting structure, we'll place our concrete slab. We'll use the length of the slab to be 10 meters and the width to be 5 meters and the thickness of 0.2 meters. The question we'll ask is how much of the slab load is carried by each of the supporting members, and we'll attempt to answer that question using tributary area analysis. Let's begin by looking at the structure from the plan view, i.e. looking from above. We can see the joists as dotted rectangles along the top and bottom edges of the slab, and the girders along the left and right edges of the slab. Previously, we defined a tributary area as being the area of the load that is halfway to the next supporting member. So when we look at the two joists, the halfway point between them is the middle of the slab as shown by the red line here. Now let's look at the top joist and the right girder. We see that they are at right angles to each other. So the line that is halfway between them extends from the corner outwards towards the center of the slab at 45 degrees to either member. And this line extends either to the middle of the next supporting element or to the boundary of another tributary area. In this case, it extends to the boundary between the two joists. Now let's look at the left girder and the bottom joist. Similarly, we can draw a line that is halfway between them, and since they are perpendicular to each other, then that halfway line is also at an angle of 45 degrees to them. We can do the same analysis for the right girder, and by symmetry, we get borders to tributary areas that look like these. The areas bounded by these lines then define the tributary area that each member under that area supports. So the top joist supports the large top trapezoid. The top half of the left girder supports the top left triangle area. The bottom half of the left girder supports the bottom left triangle area. The bottom joist supports the bottom trapezoid. And finally, the right girder supports the two triangles on the right side. Now let's look at how much area is supported by each supporting member. Let's start with the left girder. It supports a tributary area made up of two right angle triangles. Since the hypotenuse of the triangles is 45 degrees to each other, and the triangle is half the width of the slab, then the sides of the triangles must be 2.5 meters long. The area of a triangle is given by the formula half times the base times the height, where both the base and the height are 2.5 meters for our triangle. So the area of this triangle is 3.125 square meters. This area is supported by the top half of the joist. The bottom half of the joist supports the same area because the bottom triangle is identical in shape. So the left girder supports a total of 6.25 square meters of the slab. By symmetry, the right girder must also support 6.25 square meters. The area of the slab that is supported by the top joist is in the shape of a trapezoid. The formula for the area of a trapezoid is half times the height times the sum of the two parallel sides. In this case, the height is half the width of the slab, which is 2.5 meters. The longest parallel side of the trapezoid is 10 meters, and the shortest side is determined to be 5 meters. So the total area of the top trapezoid is 18.75 square meters. And by symmetry, the bottom joist also supports the same area in the lower trapezoid, so it also supports 18.75 square meters. Now, if you add up all of the areas supported by each member, you get a total of 50 square meters, which is what you would expect since the slab has the dimensions of 10 meters by 5 meters, or 50 square meters. So the girders support 25% of the slab, with each girder supporting 12.5%. And the joist supporting 75% of the slab, with each joist supporting 37.5%. After the tributary areas have been determined, the loads bearing on each supporting member can then be calculated. Remember that the load is equal to the weight of the portion of the slab in that tributary area. If you've forgotten how to calculate the loads from tributary areas, see the first video on tributary areas. Let's have a look at another quick example. Consider now that the slab has an additional joist running along its length in the center. What would the tributary area for each supporting member look like? For the top joist, it would look like this area. The middle joist would cover an area twice as large as the top joist, while the bottom joist would cover an area that's the same as the top joist. The left girder would cover the areas bounded by the two left triangles, while the right girder would cover the areas bounded by the two right triangles.